Hello, and welcome to 5-Minute Math. Today we are looking at the Algebra 1 concept of domain and range, specifically how we can find the domain and range of real-world situations, and we'll do it in 5 minutes or less. So let's start with just a definition of terms here. So when we're looking at the domain, right, so let's start with a really simple linear function here. So all possible values that can start here with my x, that's going to be my domain because those are my independent variables. So I start with my x, multiply it by 2, then I get my y. And all the possible values that I could get for this y, that is represented by my range. Those are my dependent variables, and typically those are my y values. Now, both of these in this situation are continuous, because I have not put any boundaries. I have not said they have to be less than 5 or have to be greater than 2.6. So continuous data is data that includes all measurable numbers between points. And in this case, they're between infinity. Sometimes we'll get discrete data. We'll look at that in just a moment, to where it's not all decimals and all rational numbers and real numbers between 2 points. It's just counting numbers. Whole concrete numbers determined by counting. So let's look at our first example. We have an artist prepping canvases. Each canvas will be coated with 13 ounces of eggshell white paint. So that looks like our unit rate right there. And the artist will prep no more than 6 canvases for the art show. So what is the range of the function that represents the relationship between the canvases? All right, so our canvases are going to be x. The ounces of paint are going to be y. So if we wanted to make linear function, we would look like this. Y equals, and we're going to use 13 ounces per canvas, right? So it would look like this, 13x. And we are looking for the range, right? So remember, the range is the set of our dependent variable values. That's going to be our y's, right? And we do get something here that says that they will use no more than 6 canvases, okay? So what are the possible number of ounces of paint? So the ounces of paint is my y, okay? And how many canvases can I have, right? So my x, these are going to be discrete, because what we cannot have is half of a canvas, right? They're going to be full canvases. So my x values are going to be, I can have 0 canvases, 1, 2, 3, 4, 5, 6, right? So that's going to be my domain. But I need that because each one of those canvases is going to be coated with 13 ounces of eggshell paint. So 0, one canvas would take 13, 2 would take 26, 3 would take 39, 4 would take 52, 5 would take 65, and there we go, 78. So this right here is the range. So my range is actually going to be this set right here, and this is discrete data because we're simply counting whole canvases. You can't have 0.5 canvases. That's it. So let's look at another example. So we have a Door Dasher here, and we have a graph that shows his car traveling from the pickup location to the delivery location, right? So we have our time here, x minutes. So our minutes are on our x-axis here, and the distance, right? So we started 8 miles away, went to 0 miles away, and it looks like it took 16 minutes, right, to get to the location. Kind of long for a DoorDash delivery, but that's okay. So what is the domain? All right, so remember, the domain is the set of all independent variable values. In this case, we're looking for the x values, so that's going to be our time. So you notice that we do have a line segment, so it's not all numbers here, but it is going to be continuous because we have a straight line. Discrete would have just some dots like this. So if you ever see a graph and it's like this, that means it's discrete, but we're looking at continuous data here. And so we can simply represent it like this. X is greater than or equal to 0, right? Because that's where the domain starts. And then it is less than or equal to 16, because that's where it ends. And if we wanted to do it in words, we would write it out like this.